Alright, welcome to another maths video. This one here we are talking about correlation and causation. I think this is probably the height of the unit, if you really ask me. But you know, I'm just another math teacher. Correlation, what is it? What does it mean? Well, this is we're really starting to talk about connection in data. Two or more, relation, well, normal relationship, two things relating to each other. We're talking now about the relationship between two things. So if we are talking about, your height and your weight, well, we're interested in how strong is that relationship, and well, the causation deals with if one affects the other. So correlation. Basically what we've done, we've gone through scatter plots, and in scatter plots we've gone and gone and drawn a bunch of little dot points, number parts, and this might imply if you had, say, height and weight, it looks like there's some connection between my data here. So I can draw a straight line through there. That's obviously a straight line by eye. It's not very straight, but anyway. The closer I get to a perfect straight line, the closer my data points lie to that straight line there, my correlation coefficient, which I use R for, correlation coefficient, gets closer to 1. So correlation coefficient here, this can be between -1, positive 1. Positive 1, I've got, so this one here, I'm going to get a straight line graph in the normal sense. So it looks like this, all my data points are on my straight line. Okay, if I have -1, so looking at -1 here, the graph of that is going to look like this. And again, it's a straight line, but what happens is my data points, again, all lie on the line, but as one variable gets bigger, so your height here gets bigger, your weight would get smaller. So if you're 0 tall, you might be 100 kilos. But if you get to, say, 50 tall, you're going to drop a little bit of weight. This is a negative correlation, inverse correlation, you might say. Inverse is not technically the right word, but it is still a correlation, and it's a negative correlation. So what might be 0 if you ask? Well, if you get R as 0, you get a graph that looks like this. And there is no link in your data. So the straight line, who knows where the straight line goes? It's kind of hard to draw. Doesn't really make a whole bunch of sense. So, well, after here, R is 1, R is 1, or R is -1. The closer you get to 1, the closer you get to -1, the stronger the relationship is. It's nice to know. The correlation, they're strongly correlated if it's +1, or strongly correlated at -1. Get R closer to 0, that's more weak, the correlation. We've got a positive correlation, we've got a negative correlation. Now, it's important to note that correlation does not imply causation. Correlation new pen necessary. Just going to write it all again from scratch. Correlation does not imply causation. So even if you do, what that means is, even if your data does line up, there's not necessarily a strong link between the two. There's not necessarily one thing causing the other. So in the case of body measurements, you can assume they're all fairly well linked. As you get taller, you get heavier. As you get taller, your legs grow longer, etc., etc. But this is not always the case. So it's possible, I mean, there's a lot of data out there in the world. You'll always get data sets that do kind of match coincidentally. And I'll link those in the links for this video. and I'll put them up on iLearn. But there's things like, number of movies Nicolas Cage has been in versus marriages in Maine. Like, there's so many different data sets. You can find connection between weird, random data sets where there is no connection. So there's not necessarily a cause between the two. We need to nail down your correlation coefficients. R is positive 1, nice straight line. It doesn't talk about the gradient, so the gradient we're not really concerned with at this point. We can get gradient by going on a computer, we can get gradient by measuring in our triangle. It's different to correlation coefficient. Correlation coefficient, just how close those points are to that line. And -1, same again, but just in a negative sense here. Okay, you need to be able to describe the gradient. It's positive, it's negative, it's strong, it's weak, it's moderate. You need to be able to point out the correlation coefficient being 0 as well. This, I think, is the crux of this unit, because given any data now, you can now take bivariate data. I mean, you can go and create your own survey. You can, get data off the internet, go through and find data by year and try and find connections between stuff. And if you get R being positive 1 or R being close to 1, there's a strong connection in there. And that, I think, is really kind of mind-blowing and important in terms of this unit. So look for those strong correlations, chuck a bunch of data in, go and have some fun with it. Like, go and look at weather. Like, if it rains more, is the temperature cooler? There's a whole bunch of stuff you can do with correlation. Know your definitions, get onto it. Enjoy.